Hello everyone, welcome to our final exam review for Standard 5.1. So this is going to be one of the standards that we see on the final exam. So I'm going to go over it since this is some material that you haven't seen for quite a while. We've used it, but we haven't seen it since about August or September, so it'll be good to go over it again. So let's go ahead and get started. Our goals today, we want to get ready for the test, and we also want to focus on functions along with domain and range. All right, so first thing we want to be able to do is we want to be able to evaluate and solve functions. So we have to kind of remember when we talk about functions that they give us this weird notation where they have the f and the x in the parentheses. So this really means f of x, right? Where x represents an input, and then after we calculate everything over here, we get an output, right? So we put a number in, and then we see what we get out by using order of operations and doing this calculation that they describe over here. Right? So when we read the problem here, so notice they say f of 4, right? So they put a 4 in for x, which means I'm going to take this 4, I'm going to go to my function, and I'm going to find any instance of x, and I'm going to plug that 4 in for x. All right, so when we say f of 4, this is what we get. We get f of 4 equals the square root. Now normally there would be an x here, but I'm replacing it with a 4, and then plus 2. All right, so you see the input replace the x there. So we now use order of operations. So I'm going to start with the square root. The square root of 4 is simply 2, and then we do 2 plus 2, which is 4. So interestingly enough, when I plug a 4 into this function, we get a 4 out. Okay, so this is the input, this is the output. 4 goes in, 4 goes out. All right, so let's try this one. Now this one's a little bit different. Notice they did not give us the input. Instead, they gave us the output, right? So they didn't tell us what they plugged in for x. They told us what happened after they plugged in for x, right? So this is what they got out. Okay, so I can take my function f of x, right, the square root of x plus 2, and they're saying they got a 5 out, right? So you would set it equal to 5. We need to figure out what number we would put in for x to get a 5. Okay, so we're going to use our equation solving skills to figure that out. So I'm going to draw my line, and I'm going to move things around until I get x by itself. All right, so I'm going to start with this plus 2. So I'm going to subtract 2 from both sides. All right, and the 2's cancel. So all that's left is the square root of x, and then 5 minus 2 is 3. So now we're thinking, well, what would we square root to get a 3? Well, one way we can figure that out is by, again, using our opposite operation. So the opposite of square rooting is squaring. Right? And whatever I do on one side, I got to do on the other side. So I'm just going to square both sides. So when I square a square root, the square roots and the square cancels, leaving me with just x. And then over here, if I do 3 squared, I get 9. Okay? So x equals 9. If I take a 9 and I plug it in for x, I'll get a 5 out. Okay? So make sure you pay attention to the notation. Most students, where they make their mistake, they assume that this is an input rather than an output. So the input goes in the parentheses, the output is on the other side of the equal sign. So pay attention to what they give you. Up here they gave you the input, down here they gave you the output. All right. So let's move on. This is a different type of problem. What they want you to do here, they want you to take this function and they want you to graph it. Right? So you got to produce a graph over here using this function, and then they want you to find all of the important information about this particular graph over here. So they want you to find x-intercepts, y-intercepts, vertex, minimum, maximums, all that good stuff. So we're going to go through all of that, but first I'm going to go ahead and graph. Okay, so I'm going to show you how to do that on the TI-84 graphing calculator. You are also more than welcome to use Desmos to help you with the graphing part of this problem. All right, so to graph a function, we're going to go to y equals, right? So you see our button up here in the upper left-hand corner. We're going to hit y equals, and it takes us to this screen. If you have anything in the y1 or the y2 fields, make sure you clear those out. And then I'm going to go back up to y1 and I'm going to enter in my function exactly as I see it here. So I'm going to go parentheses x plus 2 squared minus 4. All right, so I've got that entered in, and then I'm going to hit graph. So you'll notice when I hit graph, I'm zoomed out. I can see my parabola there, but I'm zoomed out quite a bit. So what I'm going to do is I'm going to hit the zoom button, and then I'm going to hit option 6, which standardizes my screen to a 10 by 10 viewing window. This should be appropriate for our parabola. There we go. So there is our parabola, and we want to graph this thing. Now when you go to graph this on MyOpenMath, the first point that they are going to want is the vertex, so you need to figure out where the vertex is, and then the second point can be any other point that's on the parabola. Now sometimes it might be hard to see exactly where the vertex is. You might be able to count out the tick marks and do it accurately that way, but a good way to confirm where your vertex is to go to your table. So if you hit the blue button, the second button, and then graph, it'll take you to your table. And since our parabola is opening upwards, we're looking for the lowest point on the parabola to confirm the vertex. So I'm looking in the y1 column, and I notice that the smallest number here is -4. All right, so when I look at that point, I can see it's located at -2, -4. That's where my vertex is. Okay, so I'm going to go ahead and plot the vertex. And then on MyOpenMath, they're going to want one other point, and you can pick any other point from this table here. So you could pick -1, -3 if you wanted to. You could pick -3, -3 if you wanted to, and either one of those points will do, right? But once you plot the vertex and one other point, MyOpenMath is going to shape the parabola for you the rest of the way. Okay, so I'm going to plot a few extra points since I'm not working with MyOpenMath here. I need to get a few more points going. Just to make sure that I draw this thing somewhat accurately for our example here. But you won't need that many points. It'll be easier for you guys. There we go. You can see my very badly drawn parabola as I try and work with this digital pen, but this is our parabola that we are working with. And I think I've got all of the important points here on the graph. So I'm going to start going through this. The first thing they want to know, where are the x-intercepts? And again, you could use your graph to help you out with that. You can see your x-intercepts located here and here. Let me make that a little bigger. All right, so we can see here at -4 and also here at 0. Now make sure when you write these as ordered pairs. So we need to write 0, 0, and then separate with a comma again. And then for our second x-intercept, that's located at -4, 0. So remember, our x-intercepts are the points where the parabola crosses through the x-axis. That would be this horizontal line that runs through the middle of the graph. All right, so this is an x-intercept and this is an x-intercept. All right, so the next thing they want to know is where are the y-intercepts, right? So remember, our y-axis is the vertical axis that runs through the middle of the graph. So this is our y-axis here. And much like the x-intercepts, we look for where the parabola crosses over that line, and that happens here. So it actually turns out that one of our x-intercepts is also a y-intercept, right? So this point 0, 0 exists on both axes. So that becomes our y-intercept. Now our vertex was one of the first things that we found in our table, right? Remember, we plotted that here, so this is our vertex. It is usually the highest point or the lowest point on the graph, depending on which way the parabola opens up, right? So this point is located at -2, 4. I'm sorry, -2, -4. And notice how I'm writing everything as an ordered pair, complete with parentheses and a comma, separating the x and the y coordinate, right? The next point is our minimum, right? This would be the lowest point on the graph, and the vertex serves as the minimum as well. So we would say that the minimum is located at -2, -4. Okay, so when we say lowest point, we mean the lowest point in relation to the y-axis, right? So this parabola gets as low as -4, right? There's no points on the parabola below -4, right? So that's how we know this is a minimum. All right, now maximum would be the same thing, but the highest point on the graph, right? So if I were going up, right, notice that we have these arrows on the end. That means the parabola never stops going up. So there will never be a highest point, right? This thing goes off to infinity. So for a maximum, we would simply say none. All right, now domain and range. Domain tells us what allowable inputs we're allowed to use in our function here. And the easy way to tell that from a graph is to ask yourself, how far to the left and how far to the right does this graph go, right? Because x, right, the x-axis runs left and right on the graph. And so if I look at this parabola, right, and I start traveling off to the left here, I notice because of this arrow, it's never going to stop going off to the left, right? So we're going to go all the way to negative infinity if I keep going this direction on the parabola. So for my domain, I'm going to say negative infinity 2. Right, and then I want to know how far to the right do I go, right? So I can go from negative infinity, and then how far to the right can I go if I follow my parabola off to the right, right? And again, we have an arrow there that says, hey, we're never going to stop. We're never going to stop going to the right, so we can go from negative infinity to positive infinity. And one of the things that we discussed in class earlier in the semester is that every parabola has the same domain. Right? Every parabola is going to go from negative infinity to positive infinity because this parabola just keeps getting wider and wider. It never stops going off to the left or the right. Right? So the range, very much like the domain, except it measures how far up and down we can go. Right? It tells us all of the possible values that we can get out of our function, which are the y values, and y's go up and down. Okay? So we want to start with how low we can go. All right, so if I'm on my parabola and I say, okay, well, how low can I go? Well, we actually already figured that out when we did the minimum. When we found the lowest point on the graph, we saw that it stopped at negative 4. Okay, so I'm going to say that my range starts at negative 4. That's the smallest number that I could ever get. And then the biggest number that I could get, right, if I follow my parabola up, it's never going to stop going up. So this actually goes from negative 4 to positive infinity. And then don't forget that for the negative 4, you're going to need a square bracket, and that is because we can actually get to the negative 4. It's included in the range. But infinity, you'll never get to infinity, so that's why we put a curved parenthesis on that one, indicating that this number here is not actually included in the range. Right? This is not a number that you can get to. All right, so there's your domain and range. The last thing we're going to talk about here is the line of symmetry. This would be the line that cuts our parabola in half, right? So vertically, right? It cuts our parabola in half vertically. So this is a line of symmetry. Let me grab a different color here so that we can see that. And the line of symmetry goes like this, right? It always runs vertically through the vertex. And the way that I know that is a line of symmetry is because if I imagine this as a fold line, if I took this parabola and I folded it in half over this line, this half of the parabola would land directly on top of this half. Okay, so that's how I know I have a line of symmetry. Now to write the line of symmetry, since it is a vertical line, it's going to be x equals whatever number that vertical line passes through. So it passes through negative 2, so we say the line of symmetry is located at x equals negative 2. You have to write it as an equation. Okay. All right, guys, so that concludes that problem. We found all the important information about that parabola, probably more than we ever wanted to know. I'm going to do one more domain and range problem with you just to make sure you got domain and range locked down for the final. So we have a function over here, right? And we want to find its domain. So remember, domain is left to right. Okay, so how far to the left can I go? How far to the right can I go? So I imagine like I'm riding a roller coaster here, right? And I'm riding my roller coaster off to the left, and it stops right here. Okay, so the furthest to the left that I can go is at negative 3. So that's where I'm going to start my domain, negative 3. And then I say, okay, well, if I rode the roller coaster the other way, if I followed this function off to the right, where would it stop? Right? And I notice the arrow tells me it's never going to stop, so this actually goes off towards positive infinity. Okay? And then I got to think about my brackets. Can I actually get to negative 3? And since that's a filled in dot, we can. So I'm going to put a square bracket on the negative 3, meaning that the negative 3 is included. And we know that we'll never get to infinity, so that's going to get a curved parentheses. Okay, so that's my domain. Now the range, right? So we're looking at range here. Remember, range is low to high, and it has to go in that order, low to high, right? So how low does it go? So if I were riding my roller coaster down, and the arrow tells me, well, this is never going to stop going down, right? So we're going to go to negative infinity, right? That's as low as it'll go. And then if I were to ride my roller coaster up, it does stop here, and the highest that point is at positive 3. So we can go from negative infinity to positive 3. We'll never get to negative infinity, but we can actually get to the positive 3. All right, guys, so that is our review for Standard 5.1. I hope you found that helpful and maybe we shook off some cobwebs there. If you have any questions, make sure you let me know in the Zoom chat. Good luck on your final exam, guys.